Guitar string oscillations. What you're seeing in these videos are the guitar strings oscillating, which are periods of harmonic motions that repeat themselves. You can see these waves due to the shutter speed of the camera being used in the bright sunlight. The camera captures the waves of the guitar strings because the strings are moving while the camera is capturing the image moving gradually in a different direction. Kind of like when you film the propeller on a plane or when a rotating car wheel looks like it's moving backwards. The kind of camera that can capture this effect are CMOS sensors, like the iPhone, because they don't capture the entire frame instantaneously and different lines are captured at different points in time, resulting in you being able to visually see the guitar waves. The camera scans over the strings very quickly to effectively show displacement versus time, with no scientific equipment needed. Even though this gives you a nice visualization of the oscillation frequency of the strings, some claim that it doesn't show exactly how the strings move and oscillate. This is because a video taken with the iPhone camera distorts your sense of how the strings are moving by instead capturing images of standing waves caused by the rolling shutter of a camera. When a guitar string, or string, is plucked and strummed, vibrations are created called standing waves. The relationship between the wavelength and frequency of the waves are shown in the equation velocity equals frequency of the wave, measured in hertz, multiplied by the wavelength. The speed of the waves depends on the tension of the string and its linear mass density. Waves travel faster on tighter strings, making the frequency of the given wavelength higher, and waves travel slower on larger strings, making their frequency much lower. The relationship between speed, tension, and mass density can be shown through the equation velocity equals the square root of tension over the linear mass of density. On the guitar, all strings use the same wavelength, so in order for the strings to have different pitches or frequencies, the strings must all have different wave speeds. In order to do this, the strings must have different tensions or have different mass densities, or a combination of the two. But if all the strings have different tensions, then some of the looser strings would therefore be harder to play. So in order to avoid this, all the tensions of the strings of a guitar remain the same and the mass density is what changes. This is why the lower frequency strings are thicker and the higher frequency strings are thinner.